Don't forget to check out the cool information and link for Altium design software later in this video. Okay guys, so in this episode we're going to check out some of the more popular software packages that we can use in our electronic projects. We are going to specifically look at four software. The first one is Fritzing, which is more used for designing circuits and wiring stuff up. iCircuit is actually a Mac application which is used for visualizing operational circuits. So you're able to see what's going on, current flow and voltages and whatnot. And LT-Spice is very similar, but it's much more complex, as you will see, as iCircuit. And it can be used to design circuits and, of course, also see their operation. More importantly, or more commonly, in time. So in the time function, or in the time domain, as it is called. And finally, we will look at Eagle. And Eagle, in that case, is a little bit more like Fritzing in the sense that it is used for designing circuits, but it is much more specialized for designing circuits that will eventually be converted into a final circuit board that the user might want to actually print and mass produce. And you can actually produce the design files that get sent, and I will put a link in the description of the video to a lot of places where you can get your boards printed. Alright, so let's take a look at these packages, starting with Fritzing. Okay guys, so we're going to look at the four software packages, but in this video we're going to look at Fritzing. Later in other videos we'll look at iCircuit and LT-Spice and Eagle. Fritzing, much like Eagle, is more for designing static circuits. Eagle is way more complex, of course, and we'll see that later on, but let's dive into Fritzing because it is very user-friendly, very intuitive, easy to use. It's got more sophistication in these schematic and PCB tabs, but we're going to focus on the breadboard and on the coding tab. So the breadboard tab is what we're going to focus on the most. I just wanted to mention the coding tab because it does allow you to write code and it does recognize keywords and whatnot. So it's a very handy feature. Alright, so let's go ahead and erase the breadboard that comes by default. And we come up here to the parts window or the parts bin, and it'll search through all the parts that come pre-installed with Fritzing. You can download parts from the net. You just Google them and download the file and then import it into Fritzing. But right now we're going to look at the parts that come with it. So there's a inspector window down here, as you can see, and gives you detailed information about that part, even measurements and whatnot. In this case, you can see the information of the breadboard. You can get the minis, the half boards, and the full boards. And obviously, when you look at other parts, such as more sophisticated components and resistors, you obviously need a lot more information. Okay, so what we're going to do here is we're going to drag an LED onto the canvas, just a simple LED. We're going to basically design the circuit that we used in the first video of our channel, which is simply lighting an LED from the microcontroller. So now we need a power source, of course. So you've got a lot of options. You got battery holders for AA's. You got CR watch battery holders. You've got LiPos, which are very common in electronic projects. And here's a tip. To make a connection, you click and drag. But if you click and drag from a component to the breadboard, it'll sometimes end up stretching the leg of that component instead of dragging an actual wire. And this is a bit of a pain. So the trick is hover over the breadboard hole, and that will give you the white circle icon with a black dot in the middle. And that means that you're actually ready to drag a wire and not extend a leg. It also works on microcontrollers. If you go to any one of the microcontroller pins and hover over it, it will easily give you the white circle with a black dot. Okay, so to add bend points, you simply click and drag as well, but you click and drag over a wire. You can rotate components, as you can see, very easily. And again, when we're making connections, we want to make the connection from the breadboard to the component, or from the microcontroller to the component. Okay, so in this case we're looking for a resistor. This is a 47 ohm, but we want 220. There it is, specified right there. 220 ohm resistor. Actually going to keep it in this orientation. And place it over the breadboard. Don't not drag from the components. Move it over the breadboard. Hover over the breadboard, and once you get the circle icon, then you can drag a wire out of there and connect the component to it. Alright, so what we want to do now is we want to finish the circuit off. Let me just drag a few more here. This is how you add the bend point. You gotta make sure that you get that angular icon while you hover over the wire. It's not always there. Sometimes you gotta mess around with it and make sure that you're over the wire itself. So, okay. Actually, let me add in. Well, we could add in a 9-volt or even a barrel jack if we wanted to power it from different sources like that. But let's go ahead and see how to use the code tab. I mean, it's not rocket science. All you do is you write code the same way you would in the IDE. But it's important to keep track of the code that goes with the circuit, because later on, trust me, you'll come back to it and you'll want to remember what the code that you used for that circuit was. We'll quickly look at the schematic and PCB tabs like I mentioned. The difference here is that it shows dotted lines, and what those dotted lines are is they're air wires. So an air wire is the difference between an electrical connection and an actual wire. So when you're placing items, especially on a PCB, as we will see later on, an air wire means there is a connection, an electric connection, which should exist between two components. But it doesn't mean that the actual physical metal wire will run through that path. So when you design a PCB, paths have to be really close to each other, they have to be tight, they have to be very precise and even in thickness to account for the current that's going to be running through it. So as you can see here, you can move components around, but until that dotted line becomes a solid line, that is not where the connection is going to go through. So there is an electrical connection between those components, but the actual trace is not really there yet. Okay, so let's go ahead and save this and move on. Okay, so we're going to load up fritzing again, show you how some parts have been removed and throws an error. Always important to learn how to deal with errors. Okay, so in this case we're going to design the project, the irrigation project, which as you recall was the first full project that we did based on the general automation model, where we combined sensing and actuating. And we're going to very quickly throw some components here on the canvas like we did before, and we'll practice a little bit more wiring things together. This is the breadboard that I want right here. And this is, I wanted to show you this, these are downloaded parts. So this relay, I had to download the file off the internet, as well as the soil moisture sensor and the rain sensor. So what you do is when there's a part that you cannot find on fritzing, you can Google for it, and once you find it, you download the file, and I believe it's got a strange end termination. I think it's FZZPZ or something like that. So you download the file to your computer, and then you go over to the parts bin and you click over here, and you can import. And you can import that part into your fritzing, and it'll be in your parts bin from then on. So this soil moisture sensor was also downloaded off the internet, and so was there's the import command, and so were a few others, and here they are. Here's the termination. It's FZPZ. So there's the rain sensor as well that we're going to need, and the controller board that comes with both the soil moisture and the rain sensor. So let's add one of these controller boards right now. And when you download these files, it's not just the graphical representation like this board right here, but it also comes with a lot of detailed electronic details that goes with each one of the pins, because when you hover over the pins of these different components, they'll actually give you information as to whether it's a VCC pin, a ground pin, a data pin, um, and a lot more sophisticated components will have a lot more sophisticated information on those pins. Alright, so now we've got most of the components down on the canvas, let's go ahead and wire stuff up. So let's get moving. Okay, so let me introduce Altium Designer. Why? Because we're building all these projects and the idea is to make a product we can sell. After all, the only thing more satisfying than a working Arduino project is a profitable one. Nowadays, you can have your prototype or final designs printed by a professional PCB service. All you have to do then is make a cool case for it, slap your logo, and ship your products. Altium is a software that lets you drag and drop your designs onto a graphical user interface and automatically route all the connections for you and even send it off to get printed. Whether you're a freelance designer or part of a multi-company team, Altium has you covered with electronic and mechanical design, online collaboration, and even connection to manufacturing. Altium is the most trusted PCB design system with over 35 years of innovation and development. So when you're ready to make some serious money, Altium takes you from the idea to product faster and without the hassle. Download a free demo and try it today. Use the link in the description below for this video. Okay guys, so let's go ahead and finish these wiring, or these connections. I'm going to fly by this a little bit just so that we can get to the end. But basically, adding bend points and changing wire colors just to keep with the protocol. I obviously try to keep my VCC wires red and my ground black. And signal cables, I usually do yellow, green, blue. And I try not to get into the more obscure colors just because it can get a little bit confusing. And then eventually you might want to reference these pictures in a forum post or to a friend. And it makes it harder to determine if something is brown or orange, dark orange, or some weird color. Here you can see I try to drag a component leg towards the breadboard, the LDR leg, and it ended up stretching the leg instead of dragging a wire. That's why I always recommend to drag from the breadboard to the component instead of from the component to the breadboard. And so let's just finish up these connections through here. And when you download these parts, they come with electrical, I mentioned they come with details on the electrical features, the pins and whatnot. That'll help you make the right connections as well. You also want to try to keep these wiring and the connections nice and neat, because when you post to a forum, you want to make sure that you get on the good side of the people that are trying to help you on the forums, because they don't like cables that overlap or cables that overlap components, because you can't tell if it's overlapping a cable or if it's actually connecting to that other cable. And when it overlaps a component, you might it just makes it harder to see where the wire is going through, or maybe you covered up a part on a component, which might have been important. So just try to keep them neat for good practice. And okay, so we're pretty much done here. And we did forget the battery, of course, so let's go ahead and bring in, I'll just bring in a LiPo. Those are pretty useful. Okay, so we're pretty much done here. And we will quickly review a little bit of the code tab and then move on to other software packages. So let's go ahead and save this. Okay, so I'm just going to shuffle some things around here so that I can make things neater. Try to get this cable right in there. And in this case, I need a wire. And what I'm going to do is I'm going to drag a wire to the component. But now I need another wire, and I can't drag from here to here. So I'm going to drag a wire from the breadboard to the air. And that'll give me a segment that I can just disconnect. And then now I can connect it to both components. Alright, so there's another little trick there. And we're done. So let's go ahead and save this before we lose it. And keep all my fritzing files in one place. And there we go. Okay, so let's quickly look at the code tab, and we'll leave the schematic and PCB for the other software packages. So, well, there's really not a lot to say. I mean, It's not rocket science. You can write code just as you would in the Arduino IDE. As you recall, we wanted to reference the pins for the inputs and the outputs, inputs being sensors and outputs being actuators. So it's a good idea to write this code now to make sure that you, as you are visually looking over your circuit, you make sure that you have variables for the components that you're going to need variables for. And it'll recognize most of the commands, as you can see here, and it'll color code it for you, which is also nice. And of course, you can always copy and paste over to your Arduino IDE. This won't compile or run code, obviously, but it's good for reference, and it's good practice, because trust me, you're never going to design a circuit and write the code for it once. Eventually, you will come back. You will want to maybe tweak it or add something different to it. And the worst thing is to find the picture or the image of the circuit that you took, or find the fritzing breadboard schematic that you drew, and then don't remember, or you don't remember where the code is. It might be an Arduino sketch named irrigation. It might be the Arduino sketch named irrigation 1, version 2, modified. Who knows? You might have changed the name to a whole bunch of different sketches, and you don't know what code goes with what circuit. So the code tab, even though all it's good for is for writing code, it's a good way to write good code, because you have a visual reference to your circuit while you're writing it, and it's also handy to keep a reference of these projects for future use. So, okay, so fritzing is pretty cool. It's easy to use, and it's very useful for initial design of circuits and for sharing circuit diagrams with people, forums, or friends. So, okay, now we will move over to other packages, and we will look at some of the more electronic aspects or dynamic aspects of circuit design in those other packages. Now, personally, I don't use fritzing, but if you want to check out a really professional tool, don't miss my next video where I'll be reviewing Altium Designer 365. This is a very professional tool. It's incredibly easy to use and incredibly popular. You don't want to miss this video, so don't forget to check it out. So see you guys next time.